Hi, welcome back to my channel. My name is Gina. In the previous lecture, we learned lines and planes in R3. If you haven't watched the video, I'll put the link up there. In this video, we are going to continue to talk about lines in R3. We are going to talk about intersections between two lines. When we have two lines, there are several possibilities. We can characterize them into two main groups, whether lines are parallel or non-parallel. If two lines are parallel, to find the intersection, we can ask, is a point on the first line also on the second line? If the answer is yes, a point from the first line is also on the second line. But since they are parallel, and one point from a line is on the second line, so they must be overlapping. So in this case, we call the two lines are coincident. What if a point from the first line is not on the second line? So here's the visualization. There are two parallel lines. A point from the first line is not on the second line. Then these two lines are parallel and distinct. They are not overlapping with each other. What if the two lines are non-parallel? Then to find their intersection, we are going to equate the x, y, and z of their parametric form, but we are going to set one of the variable as another name. Then we'll have three equations with two unknowns, the two variables. If we are able to find one solution from the system, three equations with two unknowns, then that means there's one point of intersection. But if we are not able to find a solution, because we have more equations than unknowns, so it is possible to have no solution. Then what does that geometrically mean? It means the two lines are skewed, and they do not have an intersection point. Here's the visualization. I have two lines. They are non-parallel. If there's one solution, that means one line crosses over the other line, so there's one intersection point. However, if there's no solution, that means we have two non-parallel lines, but they do not lie on the same plane. For example, this. These two lines are non-parallel, but since we are in a world of R3, so even when they are non-parallel, it is still possible to have zero intersection point. So here are the four cases. Two lines could be coincident, parallel and distinct. They could have one intersection point or zero intersection point, and when the two lines are skewed. For the first three cases, the two lines are coplanar, which means the lines lie within the same plane. But the last case, the two lines are non-coplanar. They are skewed. And here's a quick example of when I said we can set the free parameter as another name. For example, here we have two lines, L1 and L2. They do have an intersection point. They intersect at 1, -3, and 2. But from our equation, L1 passes through this point when the free parameter t equals to 1. And L2 passes through this point when t equals to -2. So the free parameter from L1 and L2 do not have to be the same value at the intersection point. Now let's look at two examples. The first one, we have two lines in parametric form. We want to find their intersection point. So first of all, we need to determine whether the two lines are parallel or not. To find whether they are parallel or not, we need to find their direction vector and check whether the components of the direction vectors are proportional. From the first line, direction vector D1 has components of 1, -1, and 2. And direction vector from the second line, D2, has components of 0, 1, and 1. From here we get that the direction vectors are non-parallel. So it could only be the third or the fourth cases. Then to find the intersection point, I need to equate the components and substitute one of the free variables with another name. For the x component, from the first line I have 3 plus t. From the second line I have 1. For the y component, from the first line I have 1 minus t. From the second line I have 4 plus the free variable, but here I'm going to name the free variable with s. And for z, from the first line I have 5 plus 2t. And from the second line I have 2 plus s. So here I get a system of equations with 3 equations and 2 unknowns. We can either have one solution or 0 solution. Let's solve this. From the first equation, I get t equals to 1 minus 3, that is negative 2. Then I substitute this negative 2 into the second equation. I get 1 plus 2 equals to 4 plus s. So s equals 3 minus 4, that is negative 1. Then I substitute t equals to negative 2 and s equals to negative 1 into the third equation. I get 5 minus 4 and does that equal to 2 minus 1. On the left I have 1. On the right I also get 1. So the answer is yes. So I get one solution. And to find the coordinates of intersection point, we can either substitute t equals to negative 2 into the first line, or substitute the free variable t equals to negative 1 in the second line. And I get 1, 3, and 1. Now let's look at the second example. Here we also have 2 lines, but the second line is given in symmetric form, but the steps are the same. First, we need to determine whether the 2 lines are parallel or non-parallel. In the first line, direction vector has components of 1, negative 1, and 2. In the second line, direction vector has components of negative 1, 3, and 2. Again, the direction vectors are non-parallel. So we are going to equate the components. For x, the first line is t. For the second line, I have 1 minus s. And for y, the first line is negative 1 minus t. For the second line is 1 plus 3s. And for z, first line is negative 4 plus 2t. And the second line is 1 plus 2s. And here again, I get a system of 3 equations with 2 unknowns. Let's solve for s and t. I'm going to substitute the t into the second equation, and I get negative 1 minus 1 minus s equals 1 plus 3s. And I get s equals to negative 3 over 2. Then I can substitute this s back to the first equation, and I get t equals 1 plus 3 over 2, that is 5 over 2. Then I'm going to substitute this 2 into the third equation. Thus, negative 4 plus 2 times 5 over 2 equal to 1 plus 2 times negative 3 over 2. On the left, I have negative 4 plus 5, that equals to 1. On the right, I have 1 minus 3, that equals to negative 2. This equation sign does not hold. So the answer is no. The 2 lines do not have an intersection point. They are non-parallel and they are skewed. And that is the end of the video. In this video, we learned how to determine whether 2 lines have an intersection point, and if they do intersect, how to find the coordinates of the intersection point. If you like my videos, please like and subscribe, and I'll see you in the next video.